you can think of memory as storage and retrieval. This is one way to think about it. Acquire, store, retrieve. So again, we can kind of split learning and memory experiments into those two bits. So learning being focusing on acquisition, memory focusing on storage and retrieval. So for experiments in learning, you manipulate conditions at acquisition, and keep the conditions for storage and retrieval consistent. And then for memory, flip it. Conditions at acquisition are consistent, and conditions at storage and retrieval are manipulated. Again, this is just one way to think about it. Some might argue that memory is all three stages. Don't worry about that too much. Think about it in this way. So memory is pretty important because it's difficult to study cognitive processes without including a memory component. Because time is always passing, right? And information is always useful, certain pieces of information, but you have to remember those pieces of information as time moves forward. You can also think of memory as behavioral change due to past experiences. We remember something, we change our behavior. A question to ask yourself is if all behaviors are reliant on learning and memory. What do you guys think? Are all behaviors reliant on learning and memory?
Probably not, because some of it might be based on genetics.
Genetics, sure.
I think like reflexes could be an example of something that isn't reliant because it's just like ingrained and like inborn, like something you're born with.
Reflexes are, yeah, good example. Good example. That's just kind of in there. Touch something hot, you don't have to learn or remember to withdraw your hand, it's an automatic process. So not all behaviors are reliant on learning and memory, but a lot of them are, right? A lot of them are. And that includes in animals as well. Animals can learn and remember. So, as we think about many topics in this course, we have to think about it through this context of evolution, or we should think about it. Memory is costly. And when I say something's costly, it takes a lot of energy. Literally, energy. So it should only exist if it improves fitness. So the question to ask is, when is it adaptive to learn and remember? There are lots of reasons to learn and remember, right? And again, we're thinking about in non-human animals, but it applies to us as well. Gotta remember where your food is. An animal needs to remember maybe different patches of food that are high quality. They have to remember where they are so they can go back to them and survive. They have to learn and remember the way home. If they have a nest or a roost, and they're going out to forage to find those food locations they remember, they have to get home. So they have to learn and remember that. It's important to learn and remember social interactions, where potential mates are, who they are. It's also important to remember your mistakes. Maybe you ate something kind of gross, made you really sick. You have to remember that. As an animal, as a non-human animal. I'm saying you, but pretend you're a non-human animal. Predator avoidance too. Where are all the predators hanging out? Important to learn and remember, right? So you can think of learning and memory in these different ecological contexts that are all pretty important. They kind of require learning and memory. You can't just randomly go out into the world, hope you find your way home randomly, hope you find food randomly. There's a system. There's learning, and there's memory. So when do animals use memory? So memory abilities are going to vary across different animals depending on their own ecological niche, their own ecological life history, their ecological context. I'm going to show you a video a bit about chickadees and caching, but I'll draw you this comparison, and I'll spoil the video a little bit. Chickadees have to store and remember the locations of thousands of seeds. That's what they do. They winter, so they store their food. Because there's fewer food resources, right, in the wintertime. So they find food, they store it, and then they have to remember where they stored it so they can eat it. That's important for them, right? It's a great example of memory in non-human animals. Now, do I need to remember the locations of thousands of seeds? No. I couldn't do it. I couldn't store 1,000 seeds and remember where I put them, unless I wrote it down. Let's imagine I have like writing utensils or anything like that. Just left to my own devices, store 1,000 seeds. I couldn't do it. None of us can do it. Because it's not important from our evolutionary history, for our ecological niche, right? But it's very important to a chickadee. So this is a very nice video from Vladimir Pravazudov's lab. And he's actually the supervisor of a recent new faculty here at Western, Carrie Branch. So if you know Carrie Branch, this is work from her supervisor in her old lab. It's a very nice video kind of showing you how the science is done.
Well, I'm Vladimir Pravazudov, first biology at the University of Arizona. My name is Ben Sonderberg. I'm one of Vladimir's graduate students in UNR's Ecology, Evolution, and Conservation Biology program. In the role, we just how animals are able to find their way around, so we don't need to navigate places. For example, Ben, where is this box close to here? 28-2 is just right over the hill. Yeah, then there's a 29, and we can remember where exactly there. We can return around the corner. There's the oil station. The bottom line is we used to find some landmark that we tried to find. Well, here we study about chickens. The birds that can catch tens of thousands of individual seed items and then remember all of their locations, which is far more impressive than a human can do. And the goal of our work is to find out how important the memory is, because it needs spatial memory to find all of these individual locations. And you need to find this food, because unlike us, if I don't find them in this box, I'll probably still have a nice lunch. But if a chicken doesn't find its caches, it most likely won't. Well, we're going to show you here our fifth study and how we study mountain chickens and how we find their caches. one of these feeders is equipped with a battery and a small computer board that opens and closes a mechanism that allows access to the seeds inside one of these feeders. And so this specific system, and its array of 8 feeders that all hang together in the woods, allows us to do memory and learning experiments on wild mountain chickadees in the Sierra Nevada. The first step to our research is to ban as many birds as we can throughout our field site. And so we set up nets around our feeder, which remain open. When the birds are coming to visit the feeder, they're flying in. They're flying in and fall into the pockets. And so between these two tram lines, there's a lot of netting. And we can just reach down and untangle them and extract them. We set these nets, and that allows us to catch these birds and then put the passive integrated transponder or pit tag on their leg. And this pit tag allows for our RFID feeders to detect specific individuals, as the pit tag has a unique 10-digit code that corresponds to each unique tag, and thus each unique bird.
07 00 EE 29
After we banded as many chickadees as we can, the next step is just to leave the feeder open until we get a lot of visitation, so birds that are coming and actively using the feeder, so birds are comfortable. When we have to 100 chickadees visiting one of our feeder sites at a given moment, that's when we actually turn on the RFID feeders, and we turn these on and we program them into all target mode, which means that any bird with a pit tag, any chickadee with a pit tag that comes and lands on a perch, one of these black perches, allows the feeder to open. It has a mechanism that opens and closes a small door and gives chickadees access to a seed inside. And so this mechanism can be a little scary at first for chickadees, and so we actually turn on all these feeders and let the birds get used to this opening and closing of the feeders before we move to the next stage of our experiment. And so when we're finally ready, and these birds are still visiting, they're habituated to the opening and closing mechanism, that's when we actually begin our memory and learning experiment. And so there are 8 feeders in an array, and we have several hundred birds visiting each location. Each one of these are equipped with a circuit board, which has a memory. We're allowed to program into this internal memory a specific set of individuals that are visiting the feeder, so a specific set of birds, and those feeders will then only open to those birds that are saved in those memories. And so we can distribute those several hundred birds across these 8 different feeders. When these specific birds come to the feeder, every single feeder was open to them before, and now only the specific feeders assigned to them will open and give them access to seeds. And this is crucial because when a chickadee comes for the first time and has its specific target feeder program, the chickadee will come and maybe land on a different feeder that it's normally been rewarded at previously, and it won't open for it, and this chickadee will then fly around the array and sample other feeders until it finds the specific feeder within the 8 that opens for it, and then it will extract a seed and fly away. And when it comes back for a second trial, it comes back to find it again. If it directly flies to that feeder that it learned opens for it, that means that it's a very superior bird and that it's using its memory, its previous experience to find that same rewarding location again. And so how many errors it makes when it's visiting our array each time allows us to measure the speed of learning and measure how well these birds are learning and memorizing these specific locations in the woods.
Well, after 2 years of studying memory in chickadees that we worked with pit tags, we did indeed find that chickadees that had facial memory survived better, and chickadees that did not have very good memory did end up dying. And this is a very exciting result because we've been hypothesized for years, but for the first time we actually were able to show this in the wild by measuring cognition of the birds in wild conditions, exactly where they are living. What we also found, which also supports the same findings, is that adult birds show that memory in juvenile birds, which is interesting, what we call the age plus comparison. So if we have more juveniles initially, they have a lot of variation, many of them are good, many of them are bad, but then the ones that are not in the family will die, so the birds becoming adults, by default, will have better memory, and we will detect it if we compare different ages. And finally, we also show that birds don't change their memory performance between years. So we found that the birds, when we tested them when they were 1 year old, showed the same performance when they were 2 years old. So suggesting that they're learning between the years, and that what we measure is a relevant trait, or special method that was likely used to find new caches. Well, so here it is. So that's the end of one part of our study.
We hope to keep this research project ongoing. We're going to keep tracking these individuals for years to come. We're excited to keep solving the GD puzzle.
If you see the birds with big tags, just let us know. Let's go. Let's go.
Alright, so that's a great example of how some of this work is done in the wild, actually. So it's pretty cool that, they can do that work in the fields. They didn't have to bring any birds into the lab and do memory experiments, right? They're doing it in the field, which is pretty neat. So, to get back to chickadees, I mentioned this before, but chickadees store lots of food items every day, from early fall to late winter. And there are different kinds of caching. So, for example, a lot of squirrels are actually larder hoarders, so they cache large amounts of food in one place. But chickadees are scatter hoarders, so they have one piece of food in several different locations. So they distribute them widely. And after a few days, they'll go and retrieve their caches to eat. So how are the chickadees finding their caches? Well, it's been spoiled a bit, but it's memory, right? They're remembering where they cache their food. And this was initially discovered by one of my late PhD supervisors, David Sherry. He discovered this. So what he had was chickadees that were going to be exposed to a room. So basically what this room has is several little trees, right? They're kind of hard to see, but there are little holes with little perches. So David made cache sites for these chickadees, and this is in the lab. Have all these trees, have all these cache sites, and then you have chickadees in the lab. You're gonna let them cache and retrieve seeds.